we are doing all of the a values together. Okay, so again, just like yesterday, we're doing the a. So it says find each real zero and its multiplicity. Determine whether it touches or crosses. Okay, so finding the zeros is the same thing as roots or x-intercepts. That means we are taking each part of the problem and setting it equal to 0. We took each thing and we set it equal to 0, and then we're going to solve it. Okay, so if 2x squared equals 0, I'm going to solve for x. So technically, I would need to divide by 2. If x squared equals 0, what's x going to be? 0. Okay, again, remember, if you're not adding or subtracting anything, it's just 0. X minus 4 equals 0, so x is going to be 4 positive, and x plus 2 is going to get you negative 2. Okay, that's really easy. From there, it says talk about its multiplicity, and that helps us to determine whether it touches or crosses. So remember, multiplicity means how many times did each answer occur. Okay, so the way we look at multiplicity is exponents. Okay, we're looking at the exponent on the outside of parentheses, if there are parentheses, to help us make that determination. Okay, so in this problem, it is 2x squared. What is the multiplicity on that problem? It's a 2. Okay, that means the answer 0 really is happening 2 times. Okay, if it happens 2 times, is it going to touch it, or is it going to cross the x-axis? It's going to touch. Okay, x equals 4. What is the multiplicity? What is the exponent on the outside the parentheses? It's a 1, so that means it crosses. And the last one, it's a 1, that means it crosses. Let me draw a really fast sketch of this. Okay, so you don't have to be perfect at this, but remind yourself of what this means. Touch and cross. That just seems like gibberish. Okay, these are zeros, so that's where I'm going to touch and cross the x-axis. I'm starting positive. You don't need to worry about why that's true for right now. I'm going to negative 2. At negative 2, I cross. I turn to go back to 0. What am I going to do at 0? Touch and go back down. And at 4, I cross. That's what that means. Okay, the degree of this problem is 4, because I could count up all the x's. There are 4 of them. That means my end behavior is going to be the same. Next one says find the vertical asymptote and the horizontal asymptote. So to find vertical asymptotes, remember that's the really easy one. To find a vertical asymptote, all you need to do is set the denominator equal to 0. So I'm going to have a vertical asymptote at x equals what here? Negative 2. At negative 2, there is going to be a break in our graph. Okay, there's going to be a vertical asymptote there. Remind yourself how to find horizontal or oblique asymptotes. Okay, anybody remember, what do we do to look for horizontal or oblique asymptotes? The exponents of the numerator and the denominator. What is the degree of the exponent on top? 1. It is x to the first power. What is the degree on bottom? 1, because it's x to the first power. So my degree and my numerator. My numerator is equal to my denominator. Okay, they're both 1. So if they're both 1, you say that you have a horizontal asymptote at y equals leading coefficients. So what is my leading coefficient on top? 3. What's my leading coefficient on bottom? 1. So my answer is 3. There's a horizontal asymptote at 3. I set x plus 2 equal to 0 and subtracted 2 over. Other questions on 11? Number 12 says find the remaining zeros of the polynomial. Remind yourself on how to find zeros. We did synthetic division to find zeros. Synthetic division, box and a line. Okay, we wrote down the leading coefficients from the problem. Okay, so for this problem right here, my leading coefficients are 1, 3, -4, and -12. 1, 3, -4, -12. Those are my leading coefficients. It says x plus 3 is a factor. It is a factor. If x plus 3 is a factor, what number are we going to put in the box? -3. If x plus 3 is a factor, what does that tell me about -3? It's one of the answers. Good. Or it's a root. It's a 0. It's a solution. That's one of my answers. -3 is one of them. If it's an answer, what am I going to get down here for my remainder? 0. How many answers is this problem going to have altogether? 3. What are we looking for that? What are we looking at? The biggest exponent. It's cubed, so I'm going to have 3 answers. We're doing synthetic division. Remember how this works. Drop the first number. It's a 1. Multiply by whatever's in the box. So we're going to multiply by -3. So -3 times 1 is -3. They're stacked on top of each other, so I'm going to add. 3 minus 3 is 0. It's on bottom, so I'm going to multiply. -3 times 0 is 0. They're stacked, so I add. -4 plus 0 is -4. It's on bottom, so I multiply. -3 times -4 is 12. They better get you 0. We knew it was an answer, so it better get me 0, and it does. Okay? Cool. There's one answer, but that's not, I knew that was an answer. I need to find the other one. If this was an x cubed problem, what does that tell you about this 1, 0, and -4? X squared. So this problem right here is x squared 0x minus 4. X squared minus 4 equal to 0. I need to solve that. Okay, so sometimes you might have to factor. In this one, all I got to do is add 4. X is going to be equal to plus or minus 2, because I would need to take the square root. Square root of both sides. So x equals plus or minus 2 and -3, my root from earlier. Those are my 3 answers to that problem. Solve the equation on number 13. We started doing this problem already on Wednesday. So you've already done this one in this week. You've forgotten, no. Okay, 9 to the 2x equals 27. 9 to the 2x equals 27. Thoughts on what I can do here to solve this problem? Same basis. You could throw exponents if you could throw logs if you really wanted to, because 2x is in the exponent, but that makes it kind of hard. Instead, I would suggest making the bases the same. So 9 and 27. Remember the bases we can use, 2, 3, or 5. What base are we going to use here? 3. So I want to rewrite both sides to be 3 to some power. So you need to remember 3 to what power gets me 9? 3 to the second power. And I'm going to multiply that by what's already there. What about on the other side? 3 to what power gets me 27? 3 to the third gets me 27. I did all the setup. Now all I got to do is solve. Okay, I've got 3 to some power equals 3 to some power. So I don't care about the bases anymore. 4x equals 3. X equals 3/4. There's my answer. Changing them to be the same base. If you can do it, that's the easiest way. X cubed minus x, oh no, that's the last one, never mind. Find the inverse of the function. Find the inverse of the function. Remind yourself, there are 2 steps to finding an inverse. The first step to finding an inverse is what? Switch x and y. So in this problem right here, remember f of x is just a fancy way of writing the letter y. So our first step is going to be flipping the x and y. So these 2 things are going to switch spots. X is equal to 2y plus 3. Flip the x and the y. 2 steps to find an inverse. Switch x and y, and then what? Solve for y. Get y by itself. So then I'm going to solve this thing. Okay, so from here, I'm going to get y by itself, so subtract 3. What else do I need to do to solve for y? Divide by 2. That cancels. Y equals x minus 3 over 2, okay, or it could be x over 2 minus 3 halves. It's the same thing, okay? Don't let one of those be different than the other. That's the same thing as that. It doesn't matter which way you write it. Questions on inverse. 2 steps. Flip x and y, solve for y. 15 is one of those ones that you're going to have to focus on and get better at. Okay, it's not an easy one. You need to make sure you understand what you're trying to do. We are trying to solve. You look at the problem, and the first thing you should notice, it has logs in it. Okay? The first thing beyond that is that you have the number, or the word log base 2 times on the same side. If you have log base 2 times on the same side, what do I need to do first? Condense, push it into one problem. So I'm going to rewrite this as log base 2, just one time. On the other side, it's equal to 3. That's fine. Okay, that doesn't change anything here. But the left side, I need to condense it first. Otherwise, you can't do anything. 4, log base 2 of 4 plus log base 2 of x. What am I doing with that 4 and the x if it's an adding? It really means multiply. Remember, addition with logs really means multiply. So that is really that 4x. What if it would have been a minus sign in between? What would have I done if it was 4 minus x? Over x. 4 over x. But there we go. We've got this set up. Okay, from here, we're trying to solve. I've got log on one side, but not the other. Okay, if log was on both sides, I could cancel them out. But I have log on one side, not the other. What's my way of solving? Log one side, not the other. First, last, second. 2 to the third equals 4x. Then I do it. 2 to the third is 8. Divide by 4. X is 2. So we look at the problem. Log is written twice. We condense it. If there's a plus sign, that means multiply. If it were a minus sign in between, that would mean divide. Okay, so we got to this step. Log was on one side and not the other, so first, last, second. Then it's just a matter of solving. Okay, that is one you need to make sure you know how to do. Graph the given exponential function. So the first thing you want to, anytime you have a graph problem, the very first decision you should make is what is that picture going to look like? This problem, okay, I don't love the way it's written because it almost looks weird. It says -2 to the x plus 3. X is in my exponent. So when x is in my exponent, what type of graph is that going to be? Exponential. That makes it either a rocket ship or a waterfall for us. What type of graph is this going to be? A rocket ship equation or a waterfall? Waterfall. Okay? How do you know it's going to be a waterfall? The negative sign tells you that it's going to be a waterfall graph. Okay? The x in the exponent makes it a rocket ship or a waterfall. The negative makes it a waterfall. Okay? So the first thing I want to do is I want to look to see where, remember, rocket ships and waterfalls have horizontal asymptotes. Okay? Whatever number is tagged on the end is going to shift us up or down. And that is going to be where our asymptote is. So if there's no number, our asymptote's at 0. Where's our horizontal asymptote going to be on this graph? Up 3. So it's going to be at y equals 3. So right here, at y equals 3, there's going to be a horizontal asymptote. Once I've made my horizontal asymptote, then I'm going to make my anchor point. Okay, remember, an anchor point is just where my graph is. Is my graph going to be above this line or below that line? Below. Why? The waterfall, it's negative. So I'm going to make it one dot below. Remember, if there was something that was added or subtracted with our x, it would shift us left or right. But there's not anything up there, so I don't do that here. It's just, I always start 1. The anchor point is always either 1 above the line or 1 below. Once you've made your first dot, then we're going to start going 2. Okay, it's like plugging in 0. If I plug in 0 into this problem, 2 to the 0 is 1 plus 3. sorry, negative 1 plus 3. It tells us to put it at 2. All right, if you're when in doubt, start plugging in numbers. Okay, so it's always going to be 1 above because technically what I'm doing is plugging in 0. My first dot was 1 below. Since it's a 2 here, it's telling me it doubles. So the first dot is 1 below. Then as I move to the right, the next one would be 2 below the line. Then the next one would be 4 below the line. And then 1, 2, 3, 4, 5, 6, 7, 8 below the line. Okay, and you know you're going to have a waterfall graph. Start close, fall off. Remember how to do domain. Okay, remember if it's an equation, it's the same question we always ask. Is this a problem a fraction? Negative 2x to the negative 2 to the x plus 3. Is that a fraction? No. Is it a radical? Is it a square root? No. So what's my domain? All real numbers. Range. My range is what y values did I use. Remember, it's going to always be the same as my horizontal asymptote. My y's. What y's did I use? Well, I started at whatever, but I'm going to be y is less than 3. Why is it less than? Because I'm below 3.